All right, I hope we're ready to go over your 401 to 403 study guide. Question number 1 says Justin makes $7.50 each time he shovels the sidewalk, but it costs him $10 for the ice melt salt per bag that he then uses after shoveling. So if Justin shovels 10 sidewalks and uses 2 bags of ice melt, how much did he profit? All right, so here's our expression. It costs he charges $7.50 repeatedly every time he shovels. So there has to be a letter, but it costs him $10 every time he has to buy a bag. So since that's happening repeatedly as well, I need another letter. And if we think about this, he's going to take his shoveling money and subtract out the ice melt money. So here's our expression. To find our answer, $7.50 times 10 sidewalks and $10 times 2 bags of snow melt. I'm going to multiply these and get $75. I'm going to multiply these and get $20. And when I subtract, he will have made a profit of $55. Question number 2 says, select all the expressions that can be represented by 50x plus 12. So because it says all, you're going to know there's probably more than one answer. So let's just think about this. The 50 is happening repeatedly, and the 12 is happening one time. I know that because 50 has the letter with it. So down at the bottom here, I have Carlos, Jose, Harku, Susie, and Heather, because I want to think about what all of their expressions are going to look like so that I can see which ones match. So it says Carlos buys 12 video games for $50 each. So I think that's just an old-fashioned multiplication problem. It looks like 12 video games times $50 each. Well, that one's not going to work. That's not matching 50x plus 12. So let me try Jose. Jose has $50 and he's earning $12 each time he babysits. So let me think about that. He has $50 and $12 every time he babysits. Well, that one's close, but that's still not right. It's not 50x. All right, let's try the next one. Harku has $12 and earns $50 each time the lifeguarding at the pool happens. All right, so has 12 and $50 repeatedly. Oh my gosh, I think we have a winner. But I can't stop there because it says select all that are going to work. So I'm going to keep going. Susie buys X concert tickets for $50 each and 1 commemorative cup for $12. Oh, I'm sorry, not 1. X cups for $12 each. You have to read carefully. So it looks like Susie is going to have $50 for every t-shirt and $12 for every cup. Well, that's not going to work. That's not 50x plus 12. All right, let's try this last one. Heather sells her only pencil sketch only for $12, and all her paintings for $50. So if I wrote that out, excuse me, one pencil sketch plus many paintings, I have another winner. Here is problem number 3. Marty bought a mega-sized box of cereal at Costco. It has 62 ounces of cereal in it. A serving is 4.5 ounces. So we want to know the amount of cereal remaining after X days. So this reminds me of the dog food problem or the leaking tanker problem. I think we're going to start Marty off with 62. Let me change my pen. He's going to start off with 62 ounces. Every time he eats, he's going to eat a serving. Every time. So that's going to have a letter. And the amount of cereal is getting less because he's eating it. There's your answer for number 3. We are ready for question number 4. So I'm going to remind you that that division sign could also be a fraction bar. So it looks like we're turning 36J divided by 9. So we are looking for the expression that looks like that. So as I'm looking, the only one is this one. Question number 5 asks you to explain how the associative property works. So let me start off by just showing you what I'm talking about. So here's an example of the associative property. And in this, I'm talking about who is associating with who. And notice the order has not changed. I have a 1, a 2, a 3, a 1, a 2, a 3. What is changing is the grouping. Here, 1 and 2 are associating or grouped together. And here it's 2 and 3 that are associating or grouped together. So the associative property says that you can change the grouping of numbers without changing the sum or product. All right, question number 6. Now that we know what the associative property does, remember, we have 1 plus 2 together plus 3 is the same as 1 plus 2 and 3 together. So remember, all that's changing is the grouping, not the order. I have 1, 2, 3, 1, 2, 3. The only changes is the grouping. So if you look at this first one, this is no property that we've talked about. Number 2, it looks like 2 and shares with 5, and 2 shares with C. So that's the distributive property. The third one, ooh, look at ABC, ABC. The only thing that's changing is the parentheses. There's 1, but I have to choose all that apply. So the next one, 398, 398. Ooh, the only change are the parentheses. That one works as well. And then the last one, it just looks like it's in a different order. So that's the commutative property. So there were 2 answers to question number 6. All right, so when we talked about the commutative property, I was talking to you about commuting, traveling from one spot to another, or changing locations. And so in this one, I had something like 3 plus 7 is the same as 7 plus 3. My 3 went from the first spot to the last spot. My 7 went from the last spot to the first spot. They changed locations. So in the commutative property, you can change the order of numbers without changing the sum or product. All right, so now we're going to choose all the expressions that show the commutative property. Remember, it was 3 plus 7 is the same as 7 plus 3. I'm just changing the order. So as I look at this first one, by golly, the order changed. That's 1. On the second one, it's the parentheses that is changing, so that is the associative property. On the third one, it looks like we are distributing. That's the distributive property. On the fourth one, oh, it's the groups that are changing. That's also associative. And on the last one, oh, they changed orders. That's 1.